We're going to talk about some geometry basics, particularly difficulties with notation. I'm assuming that you're already familiar with geometry basics, so especially those related to points, lines, and planes. If you need a refresher, pause the video and head back to the geometry section of the textbook. We're going to go to a great little site called Math is Fun that has some interactive points, lines, and planes. And then we're going to go to a drawing application and figure out why our notation is problematic. So we're working in plane geometry. These are flat shapes, so if you can draw it on a paper, you're probably in plane geometry. And we'll start with a point. According to Euclid, a point is that which has no part. Maybe an easier way to think about that is a point is something that has no dimensions, no length, width, or depth, only position. So let's click on the link. Here we have 3 points. We can move them around, we can change their position, but right away you can see we have a problem because if a point has no size, these drawings have size. Let's draw one ourselves. If I pick the smallest setting on the pencil here, I can try to draw a single dot to represent a point, and I'll label it A. We usually represent our points, but as soon as I put a mark on paper, especially I can see this if I zoom in, it has length, width, it has size associated with it. So it's impossible to draw a point and still meet the definition. So that's a problem there. And if I were to draw another, use a bigger setting here, if I'm trying to represent a point, these are still just points. They're both imperfect representations. It's not that B is a bigger point than A, because points have no size. It's just the way I've drawn it. So you can see the problem there. Okay, so let's look at lines next. A line is one-dimensional. A line is straight. It doesn't have a turn in it. It has no thickness, and it extends in both directions without end. So right away you see the problems, right? On this representation, this line in red has thickness associated with it. As soon as we put it on paper, it has thickness. And we can't draw something that goes on forever. So instead we put these little arrows on it to imply that it goes on forever, but our actual drawing does not. Here we have a line. We can have a line goes through any 2 points. I can change my points and I can draw a line through them. And by going all the way to the edge of the grid, this representation is trying to imply that the line goes on forever. We can talk about a line segment. If we cut it off at the 2 points, then this actually does have a length associated with it. We could measure it. It doesn't go on forever. And we have 2 endpoints, A and B, and the portion of the line in between those 2 points. A ray has 1 endpoint, and in the other direction, it goes on forever. So if I were to make this into a ray, I can still connect the 2 points. One of them is the starting point, we call it the end point, and the other one we pass through, and then the rest of the ray goes on forever. Let's go look at some of our problems here. Okay, so once again, if I draw a line that passes through 2 points, A and B, I'll call this line AB, and it goes on forever. Let's draw a second line with a thicker tool. So maybe this connects C and D and extends in either direction. We'd call this line CD, the points that it goes through, and put a little miniature line on top with 2 arrows. Well, it's not that one line is thicker than the other, even though in my drawing it is, because lines have no thickness. And it's not that line CD is longer than line AB. I've drawn it longer, but those arrows on the end mean that both of these lines go on forever in either direction. Let's look at some more confusion here. So rays cause a lot of issues here. I'm going to do a point A, a point B, and over here a point C, and I can draw a line AB, or sorry, ray AB, and this is AB, and on top, on one side I have an arrow where we go on forever, and the other side indicates the end point with no arrow. Now, this goes on forever to the right, so you can see that it keeps going and eventually hits C, even though I've not drawn it through C. But some people will think that if I draw ray AC, so here I have, it starts at A and continues through C and beyond. I have my lack of arrow over A and I have my arrow over C. I have two names for the same ray. So this is confusing to students because they think if you have two different letters, it must be two different rays. In this case, they're the same ray because they both extend forever. It's the same thing with a line. Up here, I could add a point E, and then I could have the line CE. I only need to write two letters, 2 points define a line. And someone might think these are different because they have different letters, but C, D, and E are collinear. They all fall on the same line. We can pick any two of the letters to name it. These are not different lines. They're different names for the same line. Now, where do we have a different ray? Let's go to a ray that starts at B and goes through A. So now I'm going to name this B, A. I'm going to have the arrow over A because it goes through A and beyond, and I'm going to have it start at B. But BA, ray BA, is different from ray AB. Another confusion that students think since they have the same letters, the same points, and they both are rays, they must be the same, but here they're going in different directions, and we can tell that based on where the arrow is. Arrow over the A or the B, meaning it goes through that point and beyond, and then where we have the end point. So those are two different rays. Okay, finally, let's look at a plane. A plane is two-dimensional, and again, we have an issue here. A plane is a flat surface with no thickness. So in this case, a lot of times we'll talk about a paper as a plane, but really we're talking about that piece of paper being the portion of a plane, because a plane goes on forever, a paper does not. And we're also just talking about the surface of that paper because a piece of paper has thickness. Think about cardstock versus a really thin dictionary page, right? A piece of paper has thickness and our plane does not. So again, we have some confusion when we try to represent it on paper when actually the paper representation cannot match our definition.